All right, so I think this is recording. Let's take a look at these three equations. They are rational equations. We know that because we see fractions and we see variables in the denominator, at least in two of the problems. When you have variables in the denominator, you have to be concerned about extraneous solutions. You have to keep in mind that we can't divide by zero. So let's jump in and solve these. When we look here at number one, let's rewrite these with a common denominator. Now, that 1, I'm going to think of it as 1 over 1. So when I look at this first term, I see a factor in the denominator of x plus 2, and I need an x minus 2 also. So I'm going to multiply this first term by the number 1, but I'm going to write 1 as x minus 2 over x minus 2. So I haven't changed the value of that first term. It looks different, but its value is the same because all we did was multiply it by 1. Second term, that we're going to do the same idea. We've got 3 over x minus 2. We're missing a factor of x plus 2, so we're going to multiply by the number 1. We're going to be clever in how we write the number 1 and write it as x plus 2 over x plus 2. Now, don't forget the left-hand side. We're going to look at 1 as 1 over 1, and we see that we're missing both of these factors. We need a factor of x plus 2, and we need a factor of x minus 2. So even though it looks a lot different, all we've done is just multiply by the number 1. So now that we have a common denominator, if every term in this equation were multiplied by that denominator, then all the denominators will cancel and all you have is the numerator. So that's what we're going to work with now is the numerator. We have this x times this binomial x minus 2. So I'm going to go ahead and distribute that now, and I have x squared minus 2x. When I look here at the next term, I have this 3 times this binomial. I'm going to go ahead and distribute that now, and I'll have 3x plus 6. And on the right-hand side, I have x plus 2 times x minus 2, which gives us x squared minus 4. All right, so I see that if you subtract x squared from each side, these x squareds cancel. On the left-hand side, I have 3x's, take away 2x. That leaves me with just x. And if I subtract 6 from both sides, then I have a negative 10. Now, I forgot to mention, when I look at this denominator and when I found this common denominator, I had to keep in mind that if we were to have a solution of negative 2, then that would cause negative 2 plus 2 would cause a 0 in the denominator. And the same thing for positive 2, that if x were allowed, if in the solution set, if it had said x equals 2, I would have had to call it extraneous because 2 minus 2 gives me a 0 in the denominator. But neither one of those things happened. My solution is x equals negative 10. And that should check, you can plug it in and check and see if the left-hand side, if that arithmetic does equal 1. If it doesn't, then I've made some silly arithmetic error. There was nothing wrong with the strategy over which we solved this. So let me shrink this up and then move on to the next one. All right, I'm going to go ahead and change colors here. Now, when I look at the next one, it's a little bit different than the first one. I don't have a variable in the denominator, so I really don't have to be concerned about extraneous solutions here. And in some situations, this might not even be called really a rational equation, although we do have fractions. The problems that are more of a challenge, that require more thought, more effort to solve, are those that have variables in the denominator. Let's get a common denominator here. Let's look at 3 as 3 over 1. and let's get a common denominator of 15. So this first term, x plus 5 over 3, we look at that denominator, we're missing a factor of 5. We're going to multiply this by 1, and we write it as 5 over 5. It's subtraction. I have my next term. I have a 5 in the denominator. It's missing a factor of 3. I multiply by the number 1, but I write the number 1 as 3 over 3. This 3 is 3 over 1, and we need a common denominator of 15. So I'm going to multiply by 15 over 15. Now, with the denominator in each of these terms being 15, if we were to multiply every term in this equation by 15, all those denominators would cancel. All we would have left is the numerator. So let's take the product of the numerator here. 5 times x plus 5 is 5x plus 25. Now be careful here with this minus sign. When I distribute this 3 through, I have to remember that I'm going to subtract each term, or I could change that to addition and change that 3 to a negative and then distribute it. But I'm just going to distribute this 3, and I would get 3x minus 3, but remember that I'm subtracting that. 3 times 15 is 45. And I didn't have to make any restrictions here. I don't have to worry about division by 0 for this problem. So we have 5x minus 3x, which is 2x. We have 25 minus a negative 3, which the double negative there turns that to adding 3, and 25 plus 3 is 28. And now if we subtract 28 from each side, we've got 45 minus 28, and 45 minus 28 is giving me 17. And so I'm getting a solution of half of 17, 17 over 2. All right. Now I hope I didn't make any type of silly error. If you do find errors in these videos, let me know, because I can come in and edit them and help other people that that I might be confusing if I make a mistake. I'm trying not to, but it's bound to happen. All right, so I'm going to do this last one in red. I'll look here, and I do see that I have variables in the denominator, so I'm concerned about extraneous solutions, values that would satisfy my equation within my work, but not satisfy this original equation. Before I jump in and try and find a common denominator, I want to factor the denominator of this right-hand side. So the left-hand side, I'm just going to copy it as is. I've got x over 2x minus 1. I'm adding this fraction 4 over x. But on the right-hand side, I'm going to move that negative sign up in the numerator. And here I see a common factor of x. I'm going to factor that x out, and I have 2x minus 1. So that's the denominator I want. I'm going to come back to this first term. I'm going to multiply this first term by the number 1, but I'm going to write 1 as x over x. Now this first term has the denominator that I need, x times 2x minus 1. This second term here, I'm going to multiply it by the number 1, but I'm going to write 1 as 2x minus 1 over 2x minus 1. The right-hand side, I'm just going to leave it alone. It has the denominator that we need. So now with a common denominator, if I were to multiply every term in this equation by that denominator, these denominators would all cancel. So the first term, I have x times x, which is x squared. And here in this second term, I have 4 times the quantity 2x minus 1. That's going to give me 8x minus 4. And the right-hand side here is a negative 4. So if I add 4 to each side, those terms cancel. If I look here to these two terms, there's an x that's common. Factor out that common x, and we see that x equals 0 is a solution, and that x equals -8 is a possible solution. And I forgot to look over here and see, well, wait a minute, 0 is not a solution, because look at our denominators. We have an x in the denominator there. We're going to have to throw out this 0. We're going to have to call this extraneous. It is a solution when we looked at the numerators there, but in the original equation, it doesn't satisfy the original equation. We have to throw that solution out. So this -8, however, it's going to be good, because the 2x minus 1, if you set that equal to 0, you would add 1 and divide by 2. We would have to throw out 1/2 as an answer and call it extraneous, but we didn't get 1/2, so we don't have to worry about it. Our final answer here for this number 3 is that x equals -8. You know, you're not going to get full credit if you claim that x equals 0 is a solution to this equation, because it's clear that you didn't check for extraneous solutions. You must do that. Please don't forget to check your answers. Don't forget to make your little marks up here to know what to avoid. We knew to avoid x equals 0. Hope that helps, and I'll talk to you later.